MODO morsels. Fantastic! In this morsel I'm going to look at two time machines. More specifically and less cryptically, we'll look at two of MODO's time modifiers, time offset and time cycler. Time offset is what you might call a copycat modifier. It will copy a float or matrix channel, but this cat is so cool that it can copy the past, the present, and some things that have not yet come to pass. In this example I have three cats. The one on the left, top cat, is animated, just like this. I would like to copy this behaviour for the other cats in the gang, but with a delay. I could replicate the animation for each cat, but this would soon become unmanageable and a huge pain in the channel. Instead, let's use the time offset modifier to copy the local transforms from top cat to his posse. We'll take the local transformation from top cat, feed it into a time offset modifier, and take the output of that and feed it into the local transformation for Spook. Take Spook's local transformation, feed it into another time offset modifier, and take the output of the offset modifier and feed it into the transformation for Benny. And we have a common control which adjusts the delay between the input and the output for both of the time offsets. With a zero delay, we get a copy of the animation. With a negative delay, Benny and Spook will follow after Top Cat's lead. But here's the cool thing. A positive delay means that Benny and Spook can look into the future of Top Cat and anticipate his movement. The Time Lords would be proud. The next time machine is the time cycler. The time cycler lets you sample an input channel between a start and end time at a point determined by the input to the completion channel. This can be very flexible because the completion channel can be any value you like at any time you like. In addition to this, you can also specify an end behavior that determines what should happen when the completion value goes outside of the range 0 to 100%. So let's see it in action. In this example, I have an animated bar. And what I would like to do is copy that animation, but at different rates on to each of the subsequent bars. This is the animation that we're going to copy. It's a simple oscillation between minus 30 degrees to plus 30 degrees over 20 frames. So we'll feed that rotation value into the input of the time cycler. We'll specify a cycle start of 0, cycle end of 20, and then we'll drive the completion channel from the current time, and we'll scale that time according to how quickly we want the animation to happen. So for the first bar in the animation, we'll use a value of 1 for the scale value, so the cycle will happen over 1 second. For each subsequent bar, however, we'll use a different time interval. And what I've done here is I'm multiplying the time coming in by a value that is incremented by a step for each of the subsequent stages in the pipeline. So for 2 bars, the schematic looks like this. For all the bars, the schematic looks rather more intimidating, but it's basically the same thing repeated over and over again. And finally, the outputs to each of these time cyclers goes into the rotation channel of each of the bars. What does it look like? Well, it's actually quite surprising. It starts off all nice and orderly, and then chaos breaks loose. And then some order reappears as if by magic. And then it's gone again. And then the magic reappears. Order is restored. At least briefly. So the advantage of using the time cycler node rather than just baking in the animations for each of the bars is that we can now go back and edit the pattern of the rotation. If we want to bias the oscillation slightly, it's a simple case of changing the reference animation and then replaying the animation. So that's just two of MODO's time machines. I hope this was useful. Thanks for watching and fantastic!